Hello guys, my name is Balkrishna Srivastav and welcome to CodeWithBK. So in this video, we look at this concept of time complexity. We also cover some parts of space complexity, and this will be very precise, especially for IC Class 12 computer science students who will be appearing for the boards paper. So we are not going to go into too much detail. The idea is to get you prepared for as much as objective questions possible that can appear for your boards exams. Okay, so let's start with what the term complexity means. So complexity comes from the fact that how complex a problem is to solve in computer science. Okay, using a program or using a code. Okay, the complexity, what defines the complexity of a program? You can think in terms of time and space. Okay, because these are the two factors that govern how complex a problem is, that is how much time it takes, okay, and how much extra space in terms of memory it takes. All right, when we say space, we say memory. Okay, so for you people, there can be a question of time complexity. There wasn't a question on space complexity in the set of practice question, but still I'll cover this because it's a simpler part, right, compared to time complexity. Okay, so we have omega notation, we have theta notation, and we have big O notation. Okay, you are concerned with big O notation. We have big omega and big theta as well. So big O basically tells you the upper bound. Just give me a minute and I'll explain you what all this means. Theta is tight bound, okay, and omega is lower bound. Okay, we are concerned with this. Now what does upper bound mean? Upper bound means that the maximum number of steps that will be taken, okay, when the code runs, code or the algorithm runs. Okay, all right, when the algorithm runs. Okay, maximum number of steps, upper bound. Now what do I mean by this is, suppose if I have a for, say I have n equal to 10, I have a for loop running for I equal to 0, I less than n, I plus plus. Okay, how many times will this loop run? You can simply say 10 times. And how do we know that? Whenever we print the value of I, we get value from 0 to 9, which is 10 values, and this loop runs 10 times. Okay, for n equal to 10, loop runs 10 times. Okay, let me make this 100. Okay, now for n equal to 100, this loop runs 100 times. Okay, all right. Okay, if I make this 1000, this will run 1000 times. Okay, so for n equal to 1000, loop runs 1000 times. Okay, so you can say the upper bound, the maximum number of steps taken when this to complete this piece of code is dependent on n as O of n. Okay, that is for n equal to 10, it takes 10 steps to complete this code. Okay, loop runs 10 times. For n equal to 100, it takes 100 steps. Okay, for n equal to 1000, it takes 1000 steps, loop runs 1000 times. So this is linear. Okay, and this is something that you need to remember, that if you have a for loop depending upon the value of n, okay, then the complexity is O n. Okay, big O complexity is O n. Okay, I use complexity slash big O complexity synonymously because we don't have to bother ourselves with omega and theta here. Okay, so complexity for this is O n. Okay, now if you want to relate this, you can think of this loop that has another j loop depending upon the value of n inside. Okay, so if I have 10 again, okay, I'm going to comment this out. Remember that for a for loop that runs depending upon the value of n, runs n times, basically has complexity O n. Okay, in this case we have an outer loop running n times, we have an inner loop running n times. Okay, so for each value of I, we have a j loop running n times. For each value of I, n times, so n into n. So for n equal to 10, loop runs 100 times. Okay, the number of steps that are taken in order to complete this piece of code is 100 for n equal to 10. Okay, so if I have something like int c equal to 1, okay, and I print c and increment it as well, okay, I get 1 to 100. Okay, all right, runs 100 times. For n equal to 100, this will run 10,000 times. Okay, so I'll get output from 1 to 10,000. So I make this n equal to 100. Okay, here I make n equal to 10. Okay, it obviously we are overwriting the value of n, so c runs 10,000 times. Okay, so the complexity for this is going to be O n square, because For a given value of n, it takes n square steps to complete this piece of code. And that is how you need to think when you're calculating the time complexity, that you are given a value of n and you have to figure out what is the function of n that this code is running on. Okay, for here in this case for n it is running in n square steps, in this case it is running in n steps, upper bound, maximum number of steps that it takes. Okay, and that is what I mean by upper bound here. Okay, so if you think of this, it cannot take more than n steps. This loop will never run for more than n times. If you make certain changes, then it will run for more than n times, and then the complexity also changes. But with given complexity n, on, it will not run more than n times. Similarly, in this case, the maximum of steps that this code takes in order to be completed is n square. Okay, upper bound is n square. Okay, let me take another loop. If I have say n equal to say 10 again, I set my counter to 1 again. I have a for loop. Okay, I say I starts from n, I is greater than 0, and I is I by 2. Okay, so in order to calculate the complexity of this, you have to determine how many times does this loop run, the number of steps taken to complete this code for a given value of n. Okay, so we can count, we can start c equal to 1 and count. So for n equal to 10, let's see how many times this runs. Let me just comment this one out. Okay, so points to remember, for a loop like this, complexity is on. Okay, depends upon the value of n. The value of I is being incremented 1 by in each iteration. In this case, in a nested for loop, both the loops running n times, it is n square. Okay, if this was running n times, this was running m times, it would be n into m, because for each value of n it runs m times. Okay, if you are able to calculate how many times the loop runs or how many steps does this code take to complete it, basically synonymous statements, right? You can figure out the complexity of the code as a function of the input. If it is something like this, okay, if I have int m equal to 20, okay, I have int j equal to 0, j is less than m, j plus plus. Okay, so in this case, okay, complexity is outer loop is n and inner loop is n into m steps. Okay, all right, we were here. Did we comment out c? We don't have to do this. Okay, so how many times will this run? Let me run this now. So we have output till 4. So counter was 1, 2, 3, 4. So the loop ran 4 times. So we can say for n equal to 10, okay, this loop runs 4 times. Okay, let me make n equal to 100. Okay, for n equal to 100, this loop runs 7 times. Okay, for n equal to 1000, okay, let's see how many times this loop runs. Okay, this loop runs how many times? 10 times. Okay, so we can say the complexity, okay, that is the number of time this loop runs based on the as a function of the input value of n is o log of n and log base 2. Okay, so when I say complexity is o log n, okay, for a simple for loop, this one complexity was n. Okay, so o n for n equal to 10 means loop runs 10 times. Okay, linear. Okay, in this case, if I set this o log n to x, base is 2, so n is 2 to the power x. Okay, in our case, n is set to 10. Okay, n is set to 10. Let's take an example of n equal to 10. So 2 to the power x has to be equal to 10. It means x has to be somewhere between 2 to the 4, 2 3 is 8, 2 to the power 3 is 8, 3 point something. Okay, in order to be equal to 2 to the power x equal to 10. So x is basically this value. Okay, it means when you replace x here, okay, log 2 is x here, so this is o 3.y, that is it takes 4 steps. Okay, for n equal to 10, which is what we have. Okay, when n equal to 100, okay, again log complexity is log n and n is 100 in this case, so log 2n is x, n is 2 to the power x, 100 is 2 to the power x, so x is somewhere between 2 to the power 5, 32, 60, 64, 6 point z, okay, which is almost 7. So when n is 100, it takes at most 7 steps. Similarly, when n equal to 1000, okay, we have log 2n is equal to x, n is 2 to the power x, and when you substitute n as 1000 here, it has to be 2 power x, then x becomes 9 point k, okay, some 9 point something, so almost 10, so that's why it is 10 steps. So that's why the complexity is O log n. That is, this loop at most will run O log n times, where with the base log n to the base 2. Okay, that's how we are calculating. So whenever you have something like this, that the value of n is being decremented by 2 by 2 by 2 by 2, starts with n, I starts with n, then by 2 by 2, it will mostly be log n. That's the idea, that's the base 2. Okay, and we have base 2 because it is being divided by 2. If you want to make this a little more complicated, I'm not sure if I should be sharing this, but let's see. If I make it divided by 3 and I say c plus plus, okay, and I start c equal to 1, okay, and for comment this out, n equal to 10, okay, for n equal to 10, this runs 3 times, okay. For n equal to 100, let's see how many times this runs. I'll make this n equal to 100, okay, it runs 5 times, okay. For n equal to 1000, let's see how many times this runs. 7 times, okay. All right, so since we were dividing by 2, base was log 2, in this case it is going to be O log base 3, okay, base 3 n, okay. This is going to be a complexity, okay, because you're dividing continuously by 3. When you're continuously dividing by 2, it is log base 2, okay. If you want to calculate it, I'm saying O log to the base 3 n is the complexity. So that is the maximum number of steps taken when n is 100, okay. So log 3n, if I put it to say x, so 3 to the power x is n is equal to 100. 3 3s are 9 square, 3 3 are 27, so 4 point something, okay. So maximum 5, so maximum 5 steps, okay. All right, this is not important for you, this is just to make you understand when you're dividing by 2, that is by base 2. When you're dividing by 3, that is by base 3, okay. All right, then what if you have a loop where it is I equal to 0, I less than n by 2, and I plus plus, okay. We look that in a moment, okay, complexity for this, okay. Then if I have a for loop, okay, running n times, then if I have a j loop inside running n times, is less than n, okay, and if I have another k loop running inside for the same n times, okay, this is 3 level of nesting, right? So this is equal to k equal to 0, k is less than n, k plus plus, okay. Basically this run n times, and for this each value of I, this run n times, for each value of ij, this run n times, so this is on cube, okay. For a given value of n, for n equal to 10, this will run 1000 times. This code takes 1000 steps basically. That is, if I have c equal to 1 again, okay, and I do this, I'll get 1 to 1000, and let me just comment this out, okay. Oh, did I choose a very large value of n? Wait 1 second, I was choosing value of n equal to 10, has to go till 1000 only, okay. If I make it 100, goes till 1 lakh, right? 10 lakhs, 10 to power 6, 10 to power 6, 10 lakhs, right? 10 lakhs, yeah, okay. All right, okay. So we have another complexity that you need to remember is O log n, okay. O n log n, sorry, n into log n, and this is the complexity for merge sort, okay, and quick sort. The time complexity O log n for merge sort and quick sort, okay. This is not in your syllabus, this is just for knowledge, okay. And for your standard algorithms, bubble sort, it is O n into n, okay, where n is the length of the array, okay. And similarly for selection sort, okay, and insertion sort, all of these have on square complexity because there's a loop inside loop, another loop that depends upon the value of n. Okay, linear search. Okay, if you are doing linear search, for example, if you have an array, okay, 2 3 5 7 8 and 9, and you're trying to find the value 9. In order to linear search, you search each location. Okay, number of values here are 6. The length of the array is 6. So the complexity for linear search is on, that is it takes at most n steps, upper bound at most n steps in order to find this value. Okay, and that is the case when the value is at the last location. Maximum number of steps taken to find this value or not linear search is going to be on. Alright, there can be a case where this value is somewhere where this value 9 that you are searching for is in the middle of the list. Okay, in this case it just takes 3 steps. Okay, upper bounds means less than equal to, that is it takes at most n steps to find. Okay, so linear search is on. Okay, binary search is okay O log n, log to the base 2n, because in every step we are dividing the sorted array by half, then by half, then by half, then by half. Okay, and what is O1? O1 means constant time. It means it takes a fixed amount of time. Okay, the time taken to execute that piece of code is independent of any value. These statements are simple statements like j equal to 10. Okay, say system out dot println say 25. Okay, these are all O1 constant time operations. Okay, it does not depend upon the value of n. If we have a string s equal to say hello, okay, and we are concatenating, string concatenation is on where n is the length of the string. Okay, this you have to remember, because when concatenating it picks up all characters then adds to all the characters, so that takes time. So this is on, you have to remember this. These operations, assignment, print, comparison, increment, these are all constant time operations. Okay, so the order that comes out, I'll go to slowest to fastest. That is the function based upon the value of n that increases the most rapidly will be the slowest. Okay, so we have on cube slower. Okay, slower, I'm saying slowest to fastest. This complexity, this takes more time than on square, takes more time than on log n, takes more time than on, takes more time than O log n. Alright, for example, if I have n equal to 10, for n equal to 10, this algorithm will take at most 1000 steps. This will take at most 100 steps. This will take n into log n. So 10 into log n for 10 comes out to be, or maximum value is 3 point something, so 40. Okay, then this comes out to be 10, this comes out to be 4, and greater than O1 it takes one single step. Okay, you can think in these terms. Okay, slowest to fastest, fastest being obviously constant, then log n, then n, then n log n. Okay, they can also ask you a question. For example, they can say, they give you a for loop. Okay, there is a print statement inside. You have c equal to 1, you have c plus plus inside. Okay, they give you one loop like this, and they give you another loop like this. I'll comment all this out. Okay, so c equal to 1 again, and I do system out. Okay, now they will ask what is the complexity of the entire piece of code. Okay, so this we know is on. Okay, then n time, linear time, this is quadratic time. Okay, square of n. Okay, so the total complexity you can add, you can say the total complexity is going to be on plus on square. Okay, which eventually evaluates to on square only, because this is the dominant part. Okay, alright, because this will grow faster compared to n. When n is 10, this is 10, this is 100. Okay, when n is 100, this is 100, this is 10 to power 4. When n is 1000, this is 1000, this is 10 to power 6. Okay, so when n is growing, this is growing much faster, so this is the term that decides the overall complexity. So on plus on square is this. You can also say on plus n square. Okay, within the brackets, it is, these two are essentially the same thing. Okay, and this also evaluates to on square. This what we call is the dominant term. Okay, there was a question on dominant term. Okay, the term that eventually decides the overall complexity. Okay, that grows the most as the value of n grows. Okay, so in order to find the dominant term, you just have to find the one which is the slowest. For example, if we have on plus n cube plus n square, the slowest is n cube, so this decides because this will grow the fastest. Okay, if we have on plus log n, then it is basically on. Okay, because this is much lower than log n. Okay, this decides. Okay, then we have if on log n plus 1. Okay, this is constant time, this is on log n. Okay, whenever you have constants, be it any number of constants, you have on cube plus 3 plus 4 plus 5 plus 6, this eventually evaluates to this, because this means you are doing n cube plus 3 plus 4 plus 5 plus 6 operations. That is, the complexity is basically something like, okay, this is n cube. Okay, then you have 3 plus 4 plus 5 plus 6 steps. It means you have 3 constant time operations. Say one is to print a line, one is to say m1 is equal to 2 int m2 equal to 3. Okay, n cube. Okay, the time complexity for this code, constant plus constant plus constant, so 3 constants. Similarly, you can have 4 more statements, 5 more statements, 6 more statements, not depending upon the value of n. These do not depending on the value of, so they all basically, you can group them all. These are basically equivalent to 1. Okay, and in order to, if you want to understand this further, you can think of this as, for example, if I have another for loop. Okay, so the complexity for this is, let me just, okay, so the eventual complexity for this is O n cube. Okay, not theta, O n cube plus 3, which evaluates to basically O n cube only. Okay, just trying to relate this example with what I said here. Okay, so there's one more thing that you need to know is, if I have a for loop something like this, does not depend on the value of n runs a fixed number of times, and fixed number of times could be 10, could be 100, could be 1000, could be 10,000, could be 10 to the power 5. It is fixed, it does not depend on the value of n, so runtime is O1 in this case, because this loop does not depend on the value of n. You might argue that this is running 1000 times, that's okay, but it will run only 1000 times, does not depend upon the value of n. Okay, so we say this is O1. That is, if we have this run 10 times, okay, for n, okay, for n we were having On, for 10 we have O10, and okay, and we treat all constants to 1, which is O1. Okay, also you should remember that if we have something like O3n square, this basically is On square only, because we treat this as 1. So O, any constant kn where k is a constant, is going to be On, and that's why if I have a loop that runs n by 2 times, the complexity still remains On, because how do we calculate this? We say complexity is O n by 2, which is O some constant k into n, which basically is On only. Alright, okay, I guess that is it about time complexity. I don't think there is anything that you guys need to know more about this. There is this order, remember this. Okay, I've also told the runtimes for standard algorithms. I have also told how to calculate. All statements are constants, you can just keep adding them. You just need to worry about the code that depends upon the value of n. How many steps does it take as a function of n based upon the given value of n? Okay, if you have multiple for loops, just add them and find the dominant term. You will have to write this entire thing. Okay, you have to say that this is the complexity which eventually evaluates this. Okay, don't just say this directly. Okay, because this will show that this might indicate to the examiner that you're not clear about the concepts. Let's just finish space complexity quickly. Okay, so space complexity is again in terms of n, how much extra memory do you need? Okay, for example, if I'm doing this bubble sort, so bubble sort was here. Okay, if I'm doing this bubble sort, right, again, and remember this variable can be anything, can be L anything. Okay, Usually we take n, and that's why you say n is the size of the array. In this case, we have L as the size of the array, so it is L square. That's it, because we're running L and L times. Okay, so even if this runs L minus 1 times, so this basically is because it is O L into L minus 1. Okay, so this is evaluating to O L square minus L square minus L, and I told you this, the term that grows the fastest determines this, eventually adds to this. Okay, that's why if you do L into L minus 1, okay, you get this. From this you can pick up this one. Okay, so the space complexity is amount of extra space required. This is a part of the input. We don't count this space. This space is already given because this is what you need to sort, right? The extra space that we need is one variable I, okay, one variable j, and one variable temp. Okay, we need 3 variables, and whatever be the size of the array, we just need 3 extra variables to bubble sort, and that's why space complexity, okay, for bubble sort is a constant. That is, you need a fixed number of space, does not depend upon the value of n, in order to do bubble sort. And same for insertion and selection. If you look at these algorithms, okay, if you look at the code, you just need variables. That's it. There is nothing that you need that depends upon the value of n in order to solve this problem. Okay, no extra space needed, only 3-4 variables which are fixed, and that is the only number of variables you need regardless of the size of the array in order to do your sorting. Okay, all right, same for linear search. Complexity is, space complexity for linear search is again O1. Okay, space complexity for binary search is also O1. Okay, so now the question is, where is the space complexity not equal to O1? It is in merge sort, which is not a part of your code, of your syllabus. For merge sort, we need On space. That is, when you're merging two arrays, you need an array of size n, an extra array of size n, and that's why we say On space. Okay, apart from the normal usual variable, so it is like On plus k, where k is a constant, so evaluates to On. Okay, all right. So space complexity is basically again the same thing. Okay, extra memory needed to solve the problem. Okay, as a function of input n. Okay, and for your standard cases, it is all 1. Okay, now if they ask you, for example, if I have a sample code here, let me just take here static void foo takes an int arr. Okay, now this code is doing something. Okay, it says does something. Okay, it creates a temp array of size new int, okay, arr dot length. Okay, does something, okay, and returns. So this algorithm is creating an array of size n. Okay, so the extra space is taken is n, so the space complexity for this entire code is going to be On. Okay, where n, you have to say where n is the length of the array arr. Okay, all right. So we have done time complexity, space complexity, constants in a complexity, the dominant term, the order. Yep, that's it. I think that should be okay for you people. Okay, all right. So, okay, you can just remember that omega is lower bound and theta is tight bound. Big O is upper bound, and that is what you need to be concerned about. Okay, the another complexity which is even slower than n cube is 2 to the power n. Okay, so for n equal to 10, it will be 2 to the power 10 is going to be 1024. Okay, it grows exponentially. Okay, so this was about time complexity. I just brushed the concepts. I did not go into too much detail. I hope this was okay, because you just need to remember a few things. This is for an objective paper. Okay, if you have any doubt, there's a part you do not understand, please let me know in the comments. I always try to answer your comments. So please like this video, subscribe to my channel, and all the best for exams. Thank you for watching.